Hello guys, welcome. This is a quick solution to a problem under sound waves for JAMB candidates. So let's assume that this question comes this way. But remember, this is a derivation. So derive the formula for speed, which is V of sound, in solid materials, okay? In solid materials. Are you here? Now, you might use this formula to solve problems, but they might not ask you to derive. But you need to know how to derive this formula by using formula analysis to find the relationship between let's say velocity, which is V, E, which is Young modulus, and density. Are we here? Now, we want to show the relationship between V, E, and P. So where V is the velocity of sound in solid materials, then E is the Young modulus, and it has to do with solid materials. Then density is also here. So solution, for us to prove that the formula for Young modulus will give us velocity of sound in solid materials, we need to follow this process. So if V is equal to the square root of Young modulus over density, then what formula can we use to show this relationship? Please note that you can use dimensional formula to show the relationship. For the sake of this tutorial, we are going to use the formula of Young modulus to connect to this velocity is equal to the square root of Young modulus over density. I hope you are following. So let's begin. We want to show the relationship now. After this, we are going to solve a mathematical problem. JAMB question will be solved. Please stay till the end. Recall that Young modulus E is equal to stress over strain. Recall it is tensile stress over tensile strain. Okay? Now, E in short form will now become force over area, all divided by extension over length. Now, this is the interpretation of the formula above. Stress is force over area, while strain is extension over length. Take note of that. So that E is equal to F over A divided by E over L. Are you here? Now, we want to connect this together and bring in velocity and also bring in density into this. Now, recall that force is equal to mass multiplied by acceleration. Are you here? Next. Now, also recall that density is equal to mass over volume. Are you here? Mass over volume. So we want to cross multiply, make mass the solid formula, so that mass is equal to density multiplied by volume. I hope you are following. We'll substitute that into the formula of Young modulus. Are you here? Let's proceed. Therefore, Young modulus E is equal to, for our force, we have mass times acceleration. So let's rewrite this as F over A times L over E. We have inverted this place by converting division sign to multiplication sign. So E is equal to mass multiplied by acceleration multiplied by length, all divided by area multiplied by extension. I hope you are following. Multiplied by extension. Please take note that we have inverted the other part. We've changed division sign to multiplication sign, and hence L becomes the numerator and E becomes the denominator. So this will give us Young modulus is equal to density multiplied by volume for mass. I hope you are getting this. Mass is density multiplied by volume. So we've substituted for mass. Then This V is not velocity, please take notice. Volume multiplied by acceleration multiplied by length, all divided by area multiplied by extension. Are we together? Now, we can reduce this. So, Young modulus is equal to, recall that you have density here and we have volume. Volume can be able to cancel our volume. So, we are going to manipulate our denominator, which is area multiplied by extension. They are all products of length. So, area is length times length multiplied by another length, which is extension. So you see that this will give us 3 dimensions of length, which will equal volume. I hope you are following. So A times E will give us V, which is volume. Please, we're going to do that now so that you can see. But E is equal to a component of length because it is measured in what? In meters. Hence, A, which is area, multiplied by extension, will equal volume, because this gives us 3 dimensions of length, which we call volume. Take note of this. So by substitution now, we now have Young modulus E is equal to density multiplied by volume. Okay, let's write it in full. Volume multiplied by acceleration multiplied by length, all divided by A times E is volume, so all divided by volume, so that volume can cancel out volume. Then we now have Young modulus E is equal to density multiplied by acceleration multiplied by length. Are you following? Then also recall, but A, which is acceleration, is equal to velocity over time. Note that this change in velocity, please, which is V over T. Are we together? So we'll substitute that into this formula now, so that our Young modulus E, okay, our Young modulus E will now equal density multiplied by V over T multiplied by L. Are you here? Then also recall that the formula for but L is equal to length, and length is in meters. Okay, likewise, distance is also in meters. So we can now replace L with distance. Hence, L is equal to D. Let's proceed. So that Young modulus E is equal to density multiplied by velocity multiplied by, let's isolate now, L over T. Okay, but note that L is distance. Okay, so L over T is equal to V. I hope you are following, because the formula for velocity is distance over time. Are you here? But L over T is equal to distance over time and is equal to V. So we'll substitute E is equal to density multiplied by velocity multiplied by velocity, so that E is equal to density multiplied by velocity squared. Our goal is to make V the subject of the formula, so that we can isolate V by dividing through by density. Okay, so that density will cancel out density. Then V squared will now equal Young modulus E over density. So take the square root of both sides, so that V is equal to the square root of E over P. Young modulus over density. We have successfully shown that the formula of Young modulus can be used to derive the formula for speed, giving us the triune components of this formula to be velocity, Young modulus, and density. So we're going to solve a problem quickly. JAMB past question. Let's solve a problem now. Now let's solve this JAMB question, okay, under sound waves. want to put the formula above into use. So given that Young's modulus for aluminium is 7.0 times 10 raised by 10 Newton per meter squared, and density is 2.7 times 10 raised by 3 kilogram per meter cube, find the speed of the sound produced if a solid bar is struck at one end, okay, with a hammer. So this is how the JAMB question looks. So we're going to solve that now. Solution. Let's extract the data. Given that Young's modulus, so our Young modulus E is equal to Young modulus E is equal to 7.0. So let's write it out. 7.0 times 10 raised by 10 Newton per meter squared. Then our density is given to be, so let's represent that density, okay, density is equal to 2.7 times 10 raised by 3 kilogram per meter cube. Now we're asked to find the speed, so we're going to do that. We'll do justice to that. So find the speed. V is equal to unknown. What formula are we going to use here? The formula that we've proven above. So we're going to use that formula now, so that we know that V is equal to, using V is equal to square root of Young modulus over density. We now have V by substitution is equal to square root, let's draw it this way, square root of 7.0 times 10 raised by 10, all divided by 2.7 times 10 raised by 3. Now if you do this, you see that V is equal to, okay, our calculator will give you V is equal to 5091.75. So if you write this in standard form, you have V is equal to 5.1 times 10 raised to the power 3 meters per second. So this is the solution to this problem. I hope you've learned one or two. This question is JAMB question on the sound waves using Young modulus. Connect to our social media handles at PhysicsBible, the Triune Physics, for latest update. Thanks for joining us. Stay equipped, stay liquid.